Hello everyone, I'm Jonas. I'm a field application engineer working at Aldebaran for Europe. In this webinar we're going to talk about Python. I will quickly introduce first the company and the NAO robot, then explain why and how to use Python to program the NAO robot. I will try to use different examples to demonstrate the different uses you could have with the Python SDK. Let's quickly talk about the company and the robot. Aldebaran is a French company. We are more than 350 employees and we have sold more than 5,000 NAOs all over the world. We are the worldwide leader in humanoid robotics at school. We provide lots of contents for the teachers to use in the classroom, and we try to adapt more and more the package to the school needs. You can see here 3 examples of books full of exercises to learn about the technology, about how to program the robot. These books are available for you to create your own classes based on full exercises. As you probably already know, NAO is a humanoid robot. It has 25 degrees of freedom, so 25 motors. It has lots of sensors, lots of actuators that are designed for interacting with humans, so it will be able to understand what you say, to recognize you, answer you in 19 different languages. It can connect to any network using Wi-Fi, and it is fully programmable. If you're interested in everything it can do, you will probably find it interesting to go to our YouTube channel. There you will find plenty of videos featuring NAO. With the robot we provide different software. The first one is choreograph, a graphical interface for visually programming the robot. We also provide webbots, a physical simulation engine, so that we'll be able to simulate all the physics, all the interaction with the environment to test programs. Monitor is a small software to visualize anything coming from the sensors of the robot. And we also provide a complete SDK if you want to program NAO using different languages, such as Python that we'll be using today, C++, Java, MATLAB, and so on. So let's now dig in the software architecture of the robot. NAO is running Linux, and on top of that we have built a middleware that we call NAOkey. NAOkey will be the base of all the interactions you will have with the robot. This middleware gives you access to different modules, such as the DCM, the video device, the audio device, that gives you access to the camera of the robot, the microphones, the speakers. And then we added lots of modules that will give you more higher level information of using the robot. For example, face detection module will provide you directly the features of the faces that NAO can see. So instead of you having to get an image from the camera of the robot and then do all the processing to find a face, find its features, and so on, we provide directly the highest level of information. When you build applications, you will ask for information from these modules and communicate with these modules. The platform is open in a way that you can add any module using our SDK. These modules can add new features to NAOkey, and your application will be able to access these modules exactly the same way as the official ones. We can see here the 2 interesting uses of Python. First one is creating applications. For embedded applications, we prefer to use choreograph. But Python could be useful for creating an app running on a computer. The second possibility to use Python is to create your own module and add new features to NAOkey. So to summarize, you would use the Python SDK for a remote control application running on a computer that would communicate remotely with the robot, or to add a new feature to NAOkey and create a new module. These are the 2 parts we're going to discuss today. Let's first imagine an application that will be running on a computer and communicating with NAO. You have 3 steps to follow when you want to call a function on the robot. First, you need to import to your Python environment the package indicating that you will be using the NAOkey SDK. Then you have to connect to a robot and to a given module of this robot. So you will provide the IP address and the module you want to connect to and use what we call a proxy. The proxy will take care of all the network communication and will give you access to all the functions of the module you're connecting to. For example, here I'm connecting to the module called AL text-to-speech, which is the voice synthesis of the robot. You have to save this proxy in a variable. I called it here TTS for text-to-speech. And then you can call a method from this module. For example, text-to-speech has a method called say. You only have to provide a string and it will just read the string and talk. So let's see how it works. I am using Eclipse with the PyDev module to code in Python. And I have just copy-pasted the code here. I just have to replace the IP address, which is 022. Play the program, which we should hear now talking.
Hello everyone. I am happy to work with you.
Alright, that was the first example. We can see that this program that was running on the computer is remotely talking with my robot, sending the order to say something, and then just waiting for data to come back, like feedback, when the speech is finished. So using this same process, you will be able to do anything with the robot, first sending orders to move or talk, but also getting data back from the robot, for example, values from sensors, images from the cameras, and do all the processing you need on these values on the computer. So as you've just seen that we can make NAO speak, just running 3 lines of code will adapt the same process to moving. We'll ask NAO to make a few steps, and for that we will use the exact same process, first importing the library, then connecting with a proxy to a different module, this time called AL motion, and then calling a function from this module, function that is called move to which you have to provide the destination you want NAO to go to. Here we'll ask NAO to move 1 meter forward and then stop. I copied the code, so I'm opening a proxy to AL motion of the same IP address as before, my robot, and asking it to move 1 meter forward. So let's play this and see NAO walking. Good. So now we know how to make NAO speak, how to make NAO walk, but what if we want to do both at the same time? So do parallel processing, speaking while walking. As most of the calls in NAO are blocking, which means that we wait for the functions to finish before executing the next one, we would need to do multithreading to execute 2 things at the same time. In NAO we have a very convenient way to do it with the keyword post, which will take care of creating a thread for you, executing the function that goes with it. Here's the code. We have to open 2 different proxies to the same robot, but to 2 different modules. As before, 1 proxy to the text-to-speech and 1 proxy to the motion. You can see the keyword post added before the function move to, so that the line motion.post.moveTo returned instantly and lets the robot execute the tts.say that follows. Let's see how it works. I copied the code. You have the 2 proxies opened on the same robot on 2 different modules. The move to with the post, and then say I can walk, let's explore the area. I run this code.
I can walk. Let's explore the area.
Now if we want to wait for both actions, move and say, to finish before executing something else, then we have this new keyword called wait. just give an argument, which is the thread created by the post, and it will wait for this thread to finish before returning. Now back to Eclipse with the same code. You see here the post that is saved in a variable thread move and the wait that waits for this thread move to finish. Let's execute.
I can walk.
And see
Let's
now
explore
walking.
the area.
When it finishes, we should say, I have reached my destination.
I have reached my destination.
Great, so we now have all the tools for doing several actions at the same time. I'm just going to quickly go through a few examples about getting the data back from NAO to have a comprehensive view of what we can do with the Python SDK. As a first example, let's just print which position NAO is currently. So this code will connect to the module air robot posture and ask this module for the name of the current posture and just print it on the console. So let's just ask now what is his posture. I'm running the code. I should print here current posture is standing. This was a first and very simple exercise about getting data back from the robot. Let's do something a bit more interesting and display an image from the camera of the robot. So I will connect to the module called AL video device, which is taking care of the two cameras, selecting the one I want. So I selected the one on top. Then I ask the module to get me an image, and I just display it with the functions that I won't be presenting here. So let's quickly go to the code. You see here the module I'm connecting to, video device. Then I just need to subscribe to the camera I want and ask for a specific resolution and color space. Then the function is very simple, get image. And this function using OpenCV will just display the function on my screen. Let's run it. And we should see a pop-up with the camera. Here it is. So with a very few lines of code, we are able to get a camera image, the posture the robot is in, but in exactly the same way we're able to get any data from any sensor of the robot. This can include the distance measured by the sonars, the temperature of the motors, how much current are currently flowing in whatever motor. So you can do pretty advanced studies with the data you get from the robot in nearly real time. I'm not going to spend more time on how to program applications in Python. You have seen here all the basis of what you need for accessing the robot or controlling the robot. With these two ways of accessing the robot, you will be able to program anything. So now let's focus on creating a new module for the robot. The first question is, why would you create a module? This is mainly for adding new features to NAOKey. As I said at the very beginning, NAOKey is featuring lots of existing modules, like the face recognition if we want to extract faces from the image NAO sees. But if you want to add something else that does not exist, then you have to create your own module, and this module can base on the other modules or directly access the camera, for example, and do its own processing. I thought a very simple example would be to use the face detection and create a new module that keeps a track of all the faces it has seen since NAO switched on, for example. So we would keep a count, we could keep stats on all the faces, and this new module would base on an existing module which is face detection, which will do all the image processing for us. And this module is itself based on a video device to get the raw images from the cameras. So we are simply adding a new level to the chain, a new level of information available for applications in NAO. In order to create a module, we have different steps to follow. The first one, of course, is writing the module. This module has to be a class that is inherited from AL module. This class has some functions, and all of this has to be advertised to NAO so that NAO knows what module and what functions are available. So there are some writing rules to follow. Here's an example. You see the creation of the class, which is inherited from AL module. To be accepted by NAO, this class has to have a description. You see here the description counts all the face scenes. And then we see the declaration of a function, getCount. And same here, if we want NAO to know this function, we need to provide a description. Here, the description is returns the count. Once this is done, then we have a class with a simple function that we have to instantiate and give to NAO. Here is how we do. We create what we call a broker that will be the link between this new class and NAO. So we have to provide the IP address of the parent NAO. Then instantiate the class. Here I'm creating a variable called faceCounter. Then we give this new object to NAO by providing the name here faceCounter. Alright, so in order to simplify here, I have written everything in the same file. So you see the instantiation of faceCounter. A faceCounter module, the class is called faceCounter module, the object will be called faceCounter. And on top here you see the creation of this module. So simply a class that inherits from AL module with a comment, a function with a comment as well. So I should run this. Alright, so we created a broker called myBroker. As I said, this creates a link between our module and the global NAO. Then you see a command that says that faceCounter has started. The beauty of my new module is that it is running on my computer right now, but NAO sees it as if it was running on itself. So you see here the IP address of my computer, which is 0.19, whereas the robot is 0.22 that you see on top. So here we have a module running on the computer and the robot accessing to the module remotely. The broker is taking care of all the communication between them two. Here I'm connected using the Wi-Fi, would be exactly the same thing using Ethernet. This can be very interesting if you have very advanced computation, a very strong computation to do. That would be too hard for the small processor in NAO, but very adapted to a computer. You could have NAO relying on a computer to do some heavy processing without being completely swamped of work doing it. Of course, if you run this exact same code on the processor of the robot, then NAO will see the module as a local module instead of a remote module, but it wouldn't change anything from application point of view. A good question is, how do I know that my module is actually running or not and correctly seen by NAO? To get the answer, you have to go to the web page of your robot, then go to the NAO page and ask for the documentation. This will open the list of all the modules available. So all the standard modules are here, but you can see here my broker. So NAO sees my broker, and if we click on my broker, we'll get to its web page with all the modules running under this broker. So here only one, faceCounter, so NAO sees the module and its documentation here. If I click on faceCounter, we should see all the documentation of this module. So all the functions that are inherited from AL module, and there is somewhere here getCount with the description I gave. So thanks to the NAO key documentation, we are able to know that NAO key sees our broker and that our module is actually available within this broker. The other way we have is to create a new choreograph box that will connect to our module called face counter exactly the same way as if it was an embedded module. Then call the function getCount of the module and see if this does run correctly or not. So in order to test this, we're going first to modify the code of the module and say here return 25 and run the new module. Then I'm going to open choreograph, create the code for this box here. So we need a proxy to my module, which is called face counter. Then we need to get the count from this module with the function called getCount. Eventually we can just output this count to the output of the box. Then just to test, I will add say text, but now it just tells me the number. Alright, so let's just run this.
25.
And now says 25, which means it has been able to contact the module running on my computer, get the count 25 that I hardcoded, and then output it on the output of the box. So from there we have all the basis for creating a module. There's only one more thing that we need if we want to actually count the faces, is to get a signal every time the robot sees a face. So for this we need to subscribe to a memory event that the module AL face detection provides. This event is called face detected, and we need to subscribe to it, which means we need to provide a function that will be called every time face detected is activated, which means every time NAO sees a face. This is a great specificity of the modules because only modules can subscribe to events and actually react on events. For subscribing, I will just add a constructor to my class so that when we start the module we do the subscription to AL face detection. I will also create a destructor so that when we exit the module then we stop also the face detection if we don't need it, and a callback function that will be called every time face detected has something. So first in the constructor and destructor we need to call the parents constructor and destructor, this for having a module working correctly, and then you can see in the middle the connection with a proxy again to the AL memory module. We don't need to provide any IP address because the broker knows already where is NAO key. So we connect to AL memory and we subscribe to the event called face detected. Face detection is what we call an extractor, which means when we subscribe to the event face detected, then AL face detection starts the detection, and when we don't need it anymore, when we unsubscribe and everyone else has unsubscribed to the same event face detected, then face detection can stop and save a processor on the robot. So with the 3 lines of code here we are subscribing to the event, giving the name on face detected to AL memory that will call this function every time face detected is activated, and give to this function the value with all the characteristics of this face. And finally, of course, this little function on face detected, which right now is only printing face detected value. This function should update all the statistics about the faces seen by the robot. So here we are back in Eclipse with the Python script. On face detected is here. It will just print the line face detected value is equal to, and then, well, the value. This function should be called every time NAO sees a face. So we should see, when I go in front of the robot, a line face detected written in the console. Let's run this new module. Alright, face counter is started, so now I will just show my face to the robot. And we are very happy to see all these lines written in the terminal. From all this data, and I must admit that face detected values are quite complex, from all this data you can extract lots of things and do statistics about where is the face, who is the face, how long am I seeing the face, and so on. So from these values you can do pretty advanced processing and keep a good track of every faces that NAO would have seen. Just to quickly summarize about this Python SDK, we have learned two things. The first one is to communicate with NAO using computer software. So if you have an existing software written in Python, why not adding 2 arms and 2 legs to this software and use NAO as the perfect way to interact with it. The second thing is adding new features to Naoki. So if you feel that something is missing in Naoki, a face counter is a very basic example, but there are probably plenty of values that could be interesting for everyone. Then you can write your own Python module, add it to Naoki. If the computation needed is too heavy, you can even run this module on a remote computer, and Naoki will access to it exactly the same way. Now I just want to add one more thing, is where do you find information? Your first source of information should be the community website. On this website, all the users of NAO are already sharing their ideas, their tips and tricks to use NAO. You have access to a documentation. If you go to the NAO software documentation, you will get access to everything regarding NAO, and in particular the Naoki API, which is the list of all the modules already available in NAO and their description. If we look at face detection that we have been using with the face detected event, we will have a quick explanation how it works, and more importantly we have the description of all the values inside of this event face detected. So you will find, for example, all the shape information of the face and all the important information to use it the best way. There is also on this same documentation a reference on how to program in Python. So I gave you the basic tricks. You have here a complete installation guide, tutorials, examples, and tips and tricks, so that you can be as efficient as possible with NAO programming in Python. On the community website you also have access to the forum, where users can share their questions if they didn't find any information. And the second source of great information is choreograph. In choreograph you have a complete list of boxes that are already programmed for you. So if, for example, you're wondering how to make NAO speak, you could just double click on the existing box, say text, and see what's inside, see the code, read the code, try to understand what it does, and eventually be able to reproduce what it does. So you would find the function say, which is right here, and try to modify the box to suit your needs. While we are on choreograph, I'll take the opportunity to show you one more thing in Python. If you want to create a movement, it's way easier to use choreograph to do so. I will use as an example the hello movement, now waves his hand. If you double click on it, you get to the timeline. You have created a very nice movement using all the features available in choreograph. But now you can right click on the timeline and export the motion in Python. I'm just going to open a text editor and paste the code, and you see here all the code needed in Python to make the exact same movement as the one you created in choreograph. This can be very useful if your application is supposed to embed movements, but you're not using any boxes from choreograph. So that's it, guys. I hope you know everything you need to know to write your own modules for one hand, and access to NAO from your existing application in Python. If you have any question, I will be happy to answer, so please use the chat box to ask them. We'll stay connected here a few more minutes, so please take this opportunity to ask everything you need to know. Thank you.